All right, we have a more complicated projectile motion problem here. I have a device that's going to shoot a piece of ammo at 50 meters per second at an angle of 36.9 degrees, and it's going to hit the target. Okay, it's going to hit the target. And we're actually going to do this such that we know the time that it's going to take to hit the target, because we want to have a particular hang time. So we're going to say that it's going to hit the target in 2.5 seconds. Now, we want to set this second device so this hits the target at the exact same time. So let's kind of picture in our head what this motion is going to look like. In one case, we're going to have, of course, this is not to scale. We're going to have the arc hit the target here. And then this one, the arc is going to hit the target, but it's going to come down and hit the target again at the same time. So we're going to have some motion that's going to look more like this. So we've got two different types of motion here. Well, it's one type of motion. It's both projectile motion, but we have two different pathways. So it's kind of a combination that we've got looking at. We're told that the height of our second device is 10 meters above, and we're told that this is 2.5. So let's look at our first velocity. So let's break up our first velocity. We're told that it's 50 meters per second, and our angle is 36.9 degrees. So let's go ahead and let's get our vector components in the x direction and our vector component in the y direction. So that's going to be 50 meters per second, and this is going to be the cosine of our 36.9 degrees. And when I plug that into my calculator, that gives me about 40 meters per second. I'm going to do the same thing for the y, except now I've got to use the sine of the angle to get my components. And when I do that, I'm going to get that this is 30 meters per second. So this gives me the information that I have, and let's kind of verify that we can do the distance and the time. So let's do the distance is going to equal our Vx times time. Our distance is 40 meters, or our velocity is 40 meters per second. Our time is 2.5 seconds. And when I multiply 40 times 2.5, I get that that's 100 meters. So we've kind of validated that we've done everything right here, and then I get that information. Well, what I want to know here is I need to know what the velocity vector is going to be in order to have it hit the target at the 2.5 seconds. Well, I'm going to have a change in my height is going to equal my initial velocity in the y direction times time. And we're going to have this in terms of gravity times time squared. Now we've got our change in height. That's got to fall a negative 10 meters. We're looking for that V naught y. We know that the time is 2.5 seconds. We know that this is 1/2 9.81. And we know that this is 2.5 seconds squared. So we've got all of that, and we can solve for our V naught y. And I'm not going to go through all of the steps, and I'm going to let you do that particular calculation here and make sure that you get it. But when I do this, I get 8.3 meters per second. So go through and do the arithmetic and see if you can get that 8.3 meters per second. So that gives me my initial velocity in the y. Well, now my initial velocity in the x, it's got to travel the same horizontal distance. So it's got to travel the 100 meters. It's got to do it in the same amount of time. It's got to do it in 2.5 seconds so that we can actually get that 2.5 seconds. And so now what I'm going to do is that distance is equal to V naught x times my time. V naught x is going to be distance divided by time. And lo and behold, I'm getting my 100 meters divided by my 2.5 seconds. And that is going to give me my 40 meters per second. So it turns out that my x direction of my vector has got to be the same as this one over here, and that turns out to be the case. So now I've got Vx of this vector is 40 meters per second. I got V naught y of this vector is 8.3 meters per second. And now I need to know what this angle is. So if I write it out in vector notation, this is going to be my vector is 40 meters per second in the I direction plus 8.3 meters per second in the J direction. And now I can calculate the angle, because remember the tangent of the angle is going to be 8.3 divided by 40. So the arc tangent is going to be my 8.3 divided by 40. And my angle is going to work out to be 11.7 degrees. So now we know what the initial velocity has got to be so that our two objects hit the same spot. So hopefully that gives you an idea about the different types of problems we might be able to do using projectile motion. I encourage you to watch some of the other sample videos. I definitely encourage you to look at your example problems in the text, but this gives you just another problem to help you with vectors.